Hello dear student, welcome in the online lecture series. I am Dr. Balasaheb Pagar, working as an associate professor in Department of Chemistry, Srimati Vimlaben Khimji Tejukaya, Art, Science and Commerce College, Deolali Camp. So in the previous lecture, we discussed about the aryl halides, reactions of the aryl halides, SN1 reaction, SN2 reaction and their mechanism discussed in the previous lecture. So nucleophilic substitution unimolecular and nucleophilic substitution bimolecular, mechanism, energy profile diagram, kinetics of the reaction and stereochemistry of the SN1 reaction, all these points discussed in the previous lecture. So student, today we discuss about the SN2 reaction stereochemistry or stereochemistry reaction of the SN2 reaction, SNI reaction and substitution versus elimination reaction. So elimination versus substitution, there is a nature of substrate as well as nature of the leaving group, stability of alkene form, solvent and temperature. So SN1 elimination or substitution, both which reaction increase or decrease, discuss in this lecture. Student must be understand or student must be draw all the mechanism, that is SN1 reaction, SN2 reaction, SNI reaction or the stereochemistry of SN1 or SN2 reaction. So student must be practice or draw the mechanisms. Student will be understand on what factor does the substitution or elimination product is formed. Means if we see the starting compounds and the reagent, both are same in case of the substitution reaction and in case of the elimination reaction. So student must be understand the effect of the leaving group, effect of the substrate, effect of the solvent. All these factors also important whenever the reaction follow through a substitution reaction or elimination reaction. First, we discuss about the stereochemistry of SN2 reaction. So stereochemistry of SN2 reaction, there is a inversion of configuration, means there is a 100% inversion of a configuration. If we see the reaction mechanism of the SN2 reaction, starting compound that slowly reacts with a reagent, means reagent and the starting compound both present in the slow step. There is formation of a 5-membered crowded state and then that 5-membered state, transition state, which is fall into the product. Means in the SN2 reaction, there is a attack of nucleophile from the back side of the leaving group. So there is a formation of transition state and then transition state convert into the product. Means attack of the nucleophile must be from the back side of the CX bond. So that's why here there is a inversion of configuration, means SN2 reaction there is a 100% inversion. So the inversion can be proved only if the reactant contain chiral center at the reaction site, means if the starting compound we use, if that compound is chiral. In such a cases, the product will certainly have the configuration opposite to the reaction, so opposite to the reactant. Means if the reactant having a plus configuration, then product must be R configuration. That indicate there is a 100% inversion. So experimental evidence support the predicted backside attack of the nucleophile and the inversion of configuration in the product. For example, when R minus 2 bromooctane is allowed to react with sodium hydroxide under the conditions where second order kinetics is followed, then the product is plus 2 octanol. So formation of the product, that is a plus 2 octanol, that indicate there is a inversion of configuration. So in this reaction, the nucleophile which is approaches from the backside of the CBr bond and there is formation of a transition state, means the formation of the carbon and oxygen bond then simultaneously there is a breaking of CBr bond takes place. Means making and breaking of the bond both takes place simultaneously. That is known as a transition state. And then transition state fast convert into the product. Means there is a removal of Br minus or leaving group bond or leaving group. Then there is formation of a product. So in this reaction there is a 100% inversion. If the starting compound is minus and product is the plus, means the starting compound is leo rotary and product is dextrorotary. That indicate there is a inversion of configuration. A reaction that yield a product whose configuration is opposite, that indicates the inversion of configuration. In the above example, the product is found to have the S configuration, whereas the reactant that have the R configuration, that indicates the inversion of configuration. This support the backside attack of the nucleophile. So this experiment support the attack of nucleophile must be backside of the CX bond, and then there is a 100% inversion. Means if in the reaction there is 100% inversion, that indicates the reaction must be follow through Sn2 mechanism. Then next point, that is a SNI reaction, substitution nucleophilic internal. Means in this reaction there is a reactant as well as the nucleophile which is present in the both present in the same molecule. For example, this is a substitution nucleophilic internal reaction. Most of these reactions proceed with the retention of the configuration. In this case, the both reagent as well as the reactant which is present in the same molecule, that's why there is a retention in configuration. Means the stereochemistry of the reactant is not changed. If the starting compound is plus, then product is also plus. For example, conversion of alcohol to alkyl chloride by the use of thionyl chloride. So thionyl chloride is the reagent that first reacts with alcohol and then first convert into the bad leaving group, that is a OH group, that convert into the good leaving group. Means in the first step there is a just conversion of a bad leaving group into the good leaving group, and in the same time and in the good leaving group there is a depart of a Cl minus that reacts from the same side, and that's why there is a retention in configuration. This reaction is carried out in a anhydrous condition. This reaction involves formation of a intimate ion pair. When the same reaction is carried out in the presence of pyridine, result into the inversion of configuration. Okay, so the alcohol first react with thionyl chloride and the alcoholic OH group that convert into the good leaving group, and then Cl minus attack from the same side and then convert into the product. See the mechanism. When S alpha phenyl ethanol reacts with thionyl chloride, gives S chloroethyl benzene by SN1 mechanism. Means the starting compound that having a S configuration and product that also having a S configuration. That indicates in a SNI reaction there is a retention in configuration. Okay, so in the if we see the mechanism, thionyl chloride first react with OH, then bad leaving group OH that convert into the OSOCl, that is a good leaving group. Then in the next step the Cl minus attack from the same side, and then there is a removal of a good leaving group. So both step takes place from the same side, that's why there is a retention in configuration. Next point, that is a elimination versus a substitution. So if we see the reactants and the reagent used for the elimination reaction and the substitution reaction, both are the same. Means the substitution means all these reactions may be follow through elimination or the substitution. Both elimination and substitution reaction require substrate with a good leaving group, and the reagent should be basic and a nucleophilic in nature. A principle: there is a competition between a substitution and the elimination reaction. Means the starting compound may be follow through the elimination reaction or the substitution reaction. So there is a competition between these two reactions. all these elimination reactions are accompanied with a substitution product and vice versa. Means all the starting compounds may be convert into the substituted product or may be convert into the elimination product. Both reactions result from backside. Both reactions result from attack on the substrate by the reagent. When the reagent acts as a nucleophile, it attacks alpha carbon from a backside to bring about the substitution product. Okay, and if the reagent acts as a base, it abstract beta proton atom to bring about the elimination product. Means if the reagent that abstract the beta proton, then elimination takes place, and if the reagent that attack from the backside, then a substitution reaction takes place. So reagent as well as the starting compound both are same in both reaction. For example, so base that reacts at a same carbon means the alpha carbon, then there is a formation of a substituted product, and if base abstract a beta proton, then there is a elimination product. So structure of the substrate. So different factors. There is a first factor, that is a structure of the substrate. As the structure of the substrate becomes more crowded, then percentage of elimination increases. Means the starting compound is more crowded, then the elimination reaction, percentage of elimination reaction is more as compared to the substitution reaction. As one proceed along the primary, secondary, tertiary, then reactivity of E2 increases and reactivity of Sn2 decreases. Means crowding at the alpha carbon increases, then elimination reaction rate increases, while the substitution reaction rate decreases. This is because of a steric hindrance, and also the like charges, there is a repulsion takes place. Increased crowding in the substrate, the nucleophile difficult to attack a carbon atom from backside. So backside attack of the nucleophile, which is more difficult due to the crowding. Means crowding increases, then backside attack, possibility of the backside attack decreases. Instead, it prefer to abstract beta proton from a leading to the elimination product, means E2 product. Secondly, if crowded substrate undergoes substitution, there is no relief from the steric strain, because in the substitution reaction there is a sp3 carbon that convert into the sp3 carbon, means there is hybridization remains same, sp3 convert into sp3. But in the elimination reaction, sp3 carbon that convert into the sp2 carbon. So bond angle in sp3 carbon there is a 109.5 degree, while in case of the sp2 carbon bond angle is 120 degree. Means the crowded group which is away from each other. If the crowding substrate undergoes substitution, there is a no relief from this steric strain, but it is undergoes elimination, then there is a change of the bond angle 109.5 to 120 degree. That's why that is a more stable. Means crowding increases, then elimination, percentage of the elimination increases, while the percentage of substitution decreases. Secondly, stability of the alkene formed. Means if in the elimination reaction the alkene formed is more stable, then that substrate undergo a elimination reaction. For example, in this reaction, the ethyl bromide there is a 99% substitution product, and in case of 2-phenyl ethyl bromide there is a 95% a elimination product. The stability of the alkene increases with increased number of alkyl substituent attached to the carbon-carbon double bond. Means if the carbon-carbon double bond which is more stable, which is attached to the more electron donating groups, then that double bond is more stable. Then such type of the substrate more prefer to the elimination reaction as compared to the substitution. Means the elimination product is more as compared to the substitution product. Second factor, that is a nature of living group. Nature of living group means if a good living group increases both reaction rate, substitution as well as elimination, because in both reaction living group depart in the slow step. A good living group promotes both substitution and the elimination. However, highly crowded living group favor elimination over a substitution. Means crowding at a living group increases, then elimination reaction rate increases more than the substitution. Thus, the percentage of elimination increases in order for the following living group. For example, N-methyl means quaternary methyl, then S-Me2, then bromine, tosylate. So, the substitution, elimination reaction rate increases, means if we use N-Me3 means quaternary methyl, then the elimination product is more as compared to the substitution product. And if we use the tosylate, then the substitution product is maybe more as compared to the elimination product. Then another factor, that is a solvent. Third effect, that is a solvent. Solvent polarity increases, then that favor the substitution reaction. Means if the solvent polarity increases, then substitution reaction rate increases while the elimination reaction rate decreases. The transition state of the elimination have the dispersion of its charges more than the transition state of the substitution. Therefore, decrease in solvent polarity favors elimination more than the substitution. And the another factor, that is a temperature. Higher temperature always favor the elimination reaction. Means the temperature factor is also most important. If the temperature of the reaction increases, that favor a more elimination product. Means the rate of the elimination increases as compared to the rate of the substitution. For example, the CH3CHBr means isopropyl bromide in presence of NaOH at a 45 degree Celsius temperature, there is a 52% elimination product, and at the higher, at a 100 degree Celsius temperature, the elimination product is near about 65%. Means elimination reaction rate increases if the temperature of the reaction increases. Similarly, temperature of the reaction increases, then substitution reaction rate decreases. So student, in this topic we discuss about the stereochemistry of Sn2 reaction, then mechanism of the SNI reaction, then elimination versus substitution. As the structure of the substrate becomes more crowded, then percentage of elimination is more as compared to the substitution. If the alkene form is more stable, then elimination is more favorable as compared to the substitution. Or the higher temperature always favor the elimination reaction as compared to the substitution. A good living group promotes both substitution as well as elimination. But at the crowding at the living group increases, then elimination reaction rate increases while the substitution reaction rate decreases. The decrease in solvent polarity favors elimination. Means if the solvent used for reaction is less polar, then rate of the elimination reaction is more as compared to the substitution. Or the solvent polarity is more, then the substitution reaction rate is more as compared to the elimination. So student must be solve the following question. What is Sn2 reaction? Explain the stereochemistry of Sn2 reaction with suitable example. So if the starting compound is the chiral that having a R configuration, means in the Sn2 reaction there is 100% inversion. If the starting compound having R configuration, then product must be S, because there is a 100% inversion. Explain with suitable example, and explain the role of nucleophile in the substitution reaction. So nucleophile, role of the nucleophile is most important, means nucleophilicity also important, and the solvent, role of the solvent, role of the temperature is also important. And if in the elimination reaction, if in the alkene form is more stable, then that substrate more favor elimination as compared to the substitution. Okay, so student, today we stop here. Alkyl halides chapter is over, and next lecture we discuss about the next chapter. Thank you very much.